Here, the simple answer to the title question is yes, because nature actually does it, but in a limited situational way. And we already make use of the effect in electronics, more on that in a bit. But the real question is, can we make greater use of teleportation? The answer to that is far more complicated. Nature only does teleportation in a very limited, very specific, and ultimately difficult to control way, to the point that we may never be able to use it to move people or apples or whatever around. In science fiction, the idea of being able to instantly teleport halfway across the universe or beam yourself from starship to starship is an extensively used one, and one that certainly has a lot of popular appeal. Imagine being able to go from Australia to Europe instantly without many hours of uncomfortable plane travel. Or even better, go from Earth to your new home on a Mars colony instantly without having to travel through space. You just need to make sure you beam from Earth into the Mars dome or underground colony and not randomly somewhere on or inside Mars. In the past, such as the days of Star Trek's original transporters as envisioned in the 60s, those also had their glitches and problems, but they were more or less instantaneous, but not really. It took time to rematerialize amid a weird, old-school sci-fi sound and fade into view, and before that, fade out. It was not instant. Indeed, you could get stuck in the transport buffer, as Scotty did in the Next Generation episode Relics, after having put himself there decades before because he crashed on top of a Dyson sphere. So teleportation basically has been envisioned as both instant and not instant in the history of envisioning it within sci-fi. But on its face, teleportation of the kind envisioned in sci-fi is, in a way, a very classical view. In short, if you collect up all the information of an object, you learn the motions, positions, bonds, and interactions, and such of everything that makes up your object, you can recreate it precisely in the world of sci-fi. So to do that, you disassemble your object, thus destroying it, incidentally, and get the information you need. Then you either move those particles or reproduce them exactly at the destination and rebuild the object. Voila! Whatever comes out is what it was at the origin point, or at least something identical to the object that was at the origin point. This would work fine for a crescent wrench or inanimate object. If you create a precise copy of that, it will be a wrench, but not so much for a conscious human. There's another dimension to that, or really any further life form. It needs to be the same organism. But that introduces a problem that gets worse with complexity: quantum mechanics. And it throws a wrench right into the works here, but not completely. The reality is that the idea of teleportation of something like an organism is fraught with intricate problems, not the least of which is the long-standing philosophical question of whether someone teleported, and this is known as the teletransportation paradox, is actually the same person that originally stepped on to the transporter pad. This will not matter to the crescent wrench. It just needs to function as a wrench. It doesn't care whether it's still its original self. Indeed, it doesn't even need to teleport. It's a tool, a piece of technology. Just send the design to the spaceship without the need to teleport one, and manufacture it on site. But if you did teleport it, the wrench would not care. For an organism like a human, when you deconstruct something and then reconstruct it, do you get a new person? Or does the original person truly teleport? Would it still be you if you did it? What are the psychological effects of that? There are many unknowns, and even if you get past that mode of thinking, and you don't mind identical copies of yourself out there, you still run into extreme complexity. Well, it should be noted, if you secretly teleported some viruses or some bacteria to a long-distance crew divorced from Earth illnesses, immune systems degraded or whatever, yeah, you might create problems through the effect of those pathogens. And the pathogens do not care if they are their original selves or not. They are, in the biological sense, in the same boat as the utterly uncaring and aloof crescent wrench that wanders the universe without motivation or direction, until a human comes along and uses it to loosen a bolt. But the wrench never knew it had fulfilled its purpose, its dream. But for sending a person, this gets many orders of magnitude more complicated. It may not translate. Whatever materializes may, or more likely, may not be you. Or to put it more disturbingly, was the original you that was deconstructed out of existence in order to make an exact copy still you? No, it probably isn't. And what would happen if the original you is not destroyed? Say you survive, but your information is still teleported and reconstructed at the destination from materials there, meaning that there are now two identical yous. This is something also explored in a sense in science fiction, perhaps most famously in Star Trek: The Next Generation, with Commander Riker having a transporter accident, and that created an identical adult twin, but not exactly the same person resulting. To define it scientifically, teleportation is simply the transfer of matter or energy from point A to point B without traditionally crossing the space between them and circumventing the time required for physical travel across space. You can't really say you teleported if you walk from your house to the gas station. That is transporting yourself classically. Here, you need to go away at point A and appear at point B without walking. You could in a way liken it to forward time travel in a sense, and that all time travel really is doing the same thing, not in space necessarily, but in time. You're just jumping forward without having to pass all the time. Same with distance and space. But here's where we start seeing hints in nature that something like this is possible. But there are huge problems. More on that in a bit. One hint is quantum entanglement. There is some kind of something, a signal if you will, though it's really not even that passes instantaneously between two entangled particles through some mechanism, regardless of distance. And it does it instantly. That's not really matter or energy though. That is a state change, and does not allow the transfer of meaningful information. It's just that one thing happens here, and another thing linked to it happens there. And it does it instantly, even if the two particles are located halfway across the universe from each other. But here's the kicker. To transfer you from point A to point B requires meaningful information, which the universe prohibits to travel faster than light for some unknown reason, other than the universe would break if it didn't. But whatever happens, state changes and entanglement cross space-time instantly, regardless of distance, through that effect. But that won't let you beam from the Enterprise to Starfleet headquarters in San Francisco. And there is the tricky problem that the particles involved had to be entangled in the first place. For the Starfleet officer, that would be transferring information, a lot of it. To actually do that and be able to control it, you come up against quantum mechanics. There is an inherent uncertainty for us about knowing the position and momentum of any individual particle. It's the nature of the beast, sadly. The more you measure here, the more ambiguous it becomes, and it's known as the Heisenberg uncertainty principle. In short, when you look at the position of a particle and try to measure it as accurately as possible, you lose the ability to know its momentum. There isn't a way around it, and that makes it a forever uncertainty. And since you don't know that, you can't teleport it reliably. Not enough information is preserved after the measurement. But there is something else there that also won't let you be Captain Kirk telling Scotty to beam you up, but does allow the transfer of some quantum information so that you can get a similar effect at the endpoint in practice. This is known as quantum teleportation, and it really isn't the same thing as how teleportation is envisioned in science fiction. You aren't actually sending a particle. What happens is that the quantum information needed to basically prepare a like target in the same quantum state can be sent. On the level of a single particle, the two end up identical, even if the original is destroyed in the scanning process. What actually gets transferred here is what you need and can work with regarding a particle, the information of an indeterminate quantum state of a particle. This gets back into entanglement. So you have two entangled particles, and one of them ends up halfway across the universe. Quantum teleportation allows you to deliberately send information to a destination without knowing the information about the particle itself. Basically, it's exempt from Heisenberg because you don't need detailed information to do this. Usually this would not be teleportation at all. It would just be sending information and doing a reconstruction. But here there are certain properties of the source system that are not sent, yet end up recreated in the reconstruction anyway, without any apparent information on that being sent. Sounds mysterious, and it was sufficient for it to get the term teleportation, but it already is done in science. There was also a proposition in 2008 that energy could be teleported, and by 2023 it had, but at microscopic scales, oddly in computers used for quantum computing research at IBM. But the real question is whether particles, matter, and the question of whether someone or something can physically teleport and remain itself. The answer there is no, except in one strange instance of quantum tunneling. There really isn't a limit to how far a particle can quantum tunnel. It's just that the probabilities drop further away from the center. This means that a random particle tunneling across the universe instantly almost never happens. But the chance for it to happen is non-zero. But when they tunnel, they tend to do it close. This is well used in modern electronics. But the one thing that changes this is time. If time in the universe is infinite, then tunneling at great distances will happen eventually. For a whole atom, say hydrogen, the chances get significantly worse, but again are non-zero if you wait long enough. For a coherent object to tunnel and reappear somewhere else in the same configuration as it was, again remains non-zero, but is so unlikely that it even tests the limits of an infinite time period. And that all assumes that the proton does not decay in the far future before any of this has enough time to happen. It very well might decay, meaning that this type of teleportation effectively never happens in this universe. But the one odd thing here is that if this non-zero type of teleportation were to happen to a human, and everything went just perfectly so, which it almost certainly wouldn't, it would amount to true, instantaneous teleportation. And since the particles themselves that make up the human were physically transported through tunneling, whatever ends up on the other side would at least have the best chance out of anything of actually being you. You would be one place one moment and another the next. But again, as unlikely as that is, teleporting intact and reappearing intact is unlikely enough, but it's even far more unlikely that you would survive this, because your chances of teleporting into deep space, probably between galaxies, is much higher than going from one habitable environment to another. This approach does not allow you to choose where you teleport to. But in the end, one has to wonder, why is the universe the way it is? What made the rules for it? Thanks for listening. I'm futurist and science fiction author John Michael Godier, currently eyeing teleportation suspiciously and contemplating how he would not set foot on the Enterprise's transporter. Jeff Goldblum told y'all in The Fly that if there is something else in the pod with you, such as a fly, you're gonna have problems that a wrench will not fix. I don't even want to contemplate what happens when you teleport a wrench and a fly. It might suddenly realize the futility of existence, loosening a bolt, only to tighten it again, forever, until too much rust sets in. Very sad indeed, and be sure to check out my books at your favorite online book retailer and subscribe to my channels for regular in-depth explorations into the interesting, weird, and unknown aspects of this amazing universe in which we live.